Okay, let's get started. The idea for today is to do a brief overview of what we're thinking in terms of block building and what are the circuits that power the Aztec network, and then move into what's the architecture of what we have deemed to be the prover node, which is the agent that will be in charge of generating proofs for the network. And we'll also discuss briefly what are the integration points that we currently have in mind for actually integrating existing infrastructure with our prover node, and also discuss about these requests for integrations that both Joe and Steve were just mentioning. By the way, I'm share screen. I can't see you guys if there are any questions, but please feel free to interrupt me at any point if there is anything you want to ask about. Okay, let's start with a brief overview of what we have in mind in terms of block building and what are the Aztec circuits. We want Aztec to be fully decentralized from day one. And that means that Aztec will not be rolling out with a centralized sequencer as most altcoins do, but rather will have a staking set of wannabe sequencers that will be chosen via random election. And for each L2 block, we'll be picking a proposer that will have the rights to propose that block to L1. Our current thinking is publishing one L2 block every between 1 and 3 L1 blocks. But that's subject to change. Pretty much every figure that you see here will be subject to change eventually. And what we're thinking is that every handful of L1 blocks, what we're calling an L2 epoch, potentially 32 L2 blocks, will upload to L1 a root rollup proof, basically a proof that verifies the integrity, the correct computation, the correct state transition of every transaction on those 32 L2 blocks within that epoch. Now, how the prover is chosen, or like how the network selects which prover will be entitled to uploading that particular proof for the epoch, is left out of protocol. What we're thinking right now is having a sequencer prover coordination mechanism entirely out of protocol, where sequencers are tasked with choosing which prover is going to be in charge of uploading that proof. Something very simple that we have in mind right now is that, let's say, the first sequencer for a given epoch has the rights of choosing which prover is going to be uploading that particular the proof for the given epoch. But again, this is something that we're currently working on the design, and we'll definitely want you guys' feedback, but that's not the scope of today's call. So let's move on briefly onto circuits. What are the circuits that power the Aztec network? For those of you that are not familiar with the architecture of Aztec, Aztec is very particular in that transactions are private first, meaning that the execution of a transaction happens part on the client, part on the server. Transactions have both a private and a public component. For everything that happens in private, clients, basically users, generate what we call a client IVC proof. That's an incremental verifiable computation proof that basically shows that all the computations that happen locally, privately on the client, on the user's device are correct. And that's what users broadcast to the network. Like if you open up a transaction object for an Aztec transaction as it's going through the P2P pool, what you will see is a client IVC proof of correct execution of what the user actually ran on their device. The side effects that occur, that span from that private execution, such as node hashes, modifiers, events, encrypted or not, whatever it is, and also requests for public execution. Aztec also has a public side of things, which works very, very similar to the EVM, in that users within their transactions, they submit requests for executing certain methods on certain contracts, and then that's executed on server side. So what you can expect from an Aztec transaction is that it has a client proof that you need to verify. And what happens once those transactions get into the prover, they get aggregated into a tree of proofs. So the first thing that happens is that this client IVC proof is transformed into a honk proof, which is our proving system, via what we call a tube circuit. From there, what we do is we execute all the public function calls that are requested within that transaction. In Aztec, one transaction can actually execute multiple function calls across multiple contracts. But this is pretty similar to what would happen on EVM lab, right? Like the sequencer will pick up and execute the transaction, and it needs to generate a proof of correct execution. That's what we call the AVM, as in Aztec Virtual Machine Proof, which is complemented by a set of public kernel proofs. Yeah, like the tube proof, the AVM, and the AVM and public kernel proofs, they're executed per transaction. And that's fed then into a tree of proofs, where the base layer of the tree is composed of what we call a base rollup circuit, and those get aggregated into a binary tree via merge rollup circuits and end up into a single root rollup proof. To make it a little bit more visual, you see on the right, what happens is, what we see are the proofs generated client side, which may or may not have public functions. And once those get into the server side, into the proving infrastructure, those are fed first into a tube circuit. They may also need to be fed into AVM and public circuits, and then they go into this tree of rollup circuits for aggregation until we end up with a single root rollup proof that basically proves the validity of the entire set of transactions in there. Our end goal is to have one root rollup proof, as we were saying, per L2 epoch, which spans roughly 32 L2 blocks. Are we good so far? Do we have any questions? Okay, let's move forward. Let's talk a bit about the prover node. So the prover node is basically an Aztec node. It's a stateful L2 node that keeps track of the current world state of the network. But the prover node has the responsibility of answering requests from whatever sequencer has been chosen to select the prover for that epoch, and to generate the proof for a given epoch. Again, this is going to be related to the sequencer prover coordination mechanism that we end up implementing, which is still under design. But basically, the prover node is going to be the counterpart to the chosen sequencer in this selection process for choosing which prover generates the proof for a given epoch. So what are the responsibilities of the prover node? Once it receives a request for proving a given epoch, it first needs to gather all the client IVC proofs, basically all the individual proofs for each transaction, either from the P2P network or from another node or from the sequencer that has made the request. Something important is that these client proofs are not submitted on chain, are not submitted to blobs, basically because they are big in size and it will be very, very expensive to upload them. And once it has gathered all the client IVC proofs, once it knows all the transactions that it needs to prove and need to go into this epoch, it re-executes all transaction public functions to get the witnesses, to get the traces for the AVM proofs, and orchestrates the proving relying on a fleet of prover agents. Basically, the prover node is the guy that keeps track of state, gathers all the information both from the network and from public execution, and then dispatches jobs to dump prover agents that are completely stateless, and they just understand, given a set of inputs, given a circuit, what proof they need to generate, and they report back to the prover node, who is also in charge of gluing together all the outputs and inputs from the different circuits. The orchestrator will make sure that once a tube circuit is run, the output of that will get fed into a base rollup. Once two base rollups are ready, that gets fed into a merge, and so forth and so forth. Basically, that's all handled by the orchestrator within the prover node. Once the root rollup proof is ready, the prover node is in charge of submitting that to the L1 contract. High level, this is the current architecture of the prover node. Once, I'm not sure if you guys, let's see, not sure if you guys can see the cursor, but the sequencer, the chosen sequencer is going to ask the prover node to generate a proof for a given epoch, and the prover node is going to gather both the transactions for this epoch and the transaction identifiers and the transactions themselves, along with their client IVC proofs from both the L1 rollup contract and the P2P network. It's going to rely on a local AVM executor, a local AVM simulator actually, to execute the public functions and gather the traces, and push that into the orchestrator, which is in charge of converting all these individual transactions into actual proving job definitions, which are very, very clear definitions of, given the circuit, given the set of inputs, given this recursive, this aggregation object, this recursive proof, please generate the next proof that we need. That gets pushed into a queue, and we have a fleet of proving agents that are constantly pulling jobs from that queue, executing them and pushing them back, which get fed into the proving orchestrator. And well, once this process is ready, the prover node is in charge of submitting the proof to the L1 verifier contract. This is probably one of the most meaningful slides in this talk because it shows what we expect you guys to be running for this initial integration period, and we'll go more in detail to that in the next section of the talk. But basically, the main goal here is to show what software we're currently shipping for proving. And our initial assumptions are that this prover node is going to be most likely Aztec software, that because it has the logic for executing our transactions, running the simulations, designing, like basically converting a set of transactions into the actual definition, sequential definition of jobs that need to be executed. But this fleet of proving agents is where we have more flexibility for integration. And we see this line here, either here or here, like at some point before or after the queue, where we can have this prover node integrate with existing infrastructure, where we can have proving agents that are not necessarily Aztec proving agents, but agents from existing infrastructure that you guys are running or know about. Those are the ones pulling the job definitions from the orchestrator and pushing them back. And when we talk about a proving agent, basically what we're talking, as we were saying, is a stateless process that receives proving jobs definitions from a given queue, basically pulls them into this architecture, and it relies on two lower level components. The ACVM, which is what we use for simulating the circuit, basically for executing the circuit and generating the full trace. And that gets fed into Barrettenberg, which is our cryptographic library, our cryptographic proving backend that actually generates the honk proofs here. Both the ACVM and Barrettenberg have native CLI interfaces, which is what the prover agent is using behind the scenes. Today, the prover agents that we ourselves are running in our internal test networks are running between 16 and 32 cores and between 64 and 128 gigabytes of RAM. This is changing fast. We expect to get back to you guys with more concrete hardware requirements shortly. But for you to have a ballpark idea, this is what we're currently seeing. So before we go into this actual integration testnet that we're talking about, do you have any other questions? Okay, let's move forward. So let's talk about this integration phase, this prover net, as we're calling it. The end goal of this testnet is to test that we can generate proofs for the network. Sorry, that you guys can also generate proofs for the network. Basically, anyone who wants to participate as a prover for Aztec, they can join the network and they can create valid proofs and upload them. We will not be testing here sequencer prover coordination for the main reason that it's not currently implemented, and it's not what we want to focus about on this stage. We'll also not be testing decentralized sequencing in this particular testnet. We have another testnet in which we're working on decentralized sequencing. Here, we want to keep sequencing simple, so we'll be running a centralized sequencing ourselves to post blocks regularly. What we're currently thinking is working with smallish blocks at about one per minute. This could change, and most likely at some point during the testnet, we'll want to start producing bigger and bigger blocks to see how much our current infrastructure can handle. But again, like this, all these numbers are subject to change, but want to give you guys a rough idea. This testnet is going to be permissioned, mostly because we still don't have in place all the algorithms for slashing, for ensuring correct behavior from all participants. So we want to make sure that everyone that participates is operating in good faith. So just for the scope of the integration testnet, that participation from provers is going to be permissioned. Again, Aztec is going to be fully decentralized and permissionless for participation. And the way we're thinking about this is, instead of going for a proof race, rather allowing everyone to generate proofs for any block. This means that once the sequencer posts a block to L1, anyone can submit a proof for it. And what's more than one party can submit a proof for it. So we can have a dozen proofs for the same block. Why? Because we don't really care about being efficient, being cost efficient here. What we care about is seeing that everyone who wants to produce a proof is able to do so. And another deviation from the design that we were discussing at the very beginning is that we won't have the concept of epochs. We'll be generating one proof per L2 block for the sake of simplicity. So that means that we'll have a centralized sequencer posting one block every minute or so, and prover nodes will be monitoring these blocks that get posted to L1 and will automatically download all the information they need for proving that, and then subsequently uploading the proof. This mechanism is already built in the prover node that we currently have, which means that there is no need for sequencer prover coordination. Coordination happens via L1. Basically, prover nodes are monitoring the rollup contract on L1, and whenever they see a new block being posted, they automatically start generating the proof for it and trying to upload it. Again, there's no coordination between sequencers, no coordination between provers. We just want to send as many proofs as we can to make sure this is doable. I see we have a question.
Yes, sorry. Thank you for the explanation. Are there any sort of restriction in terms of timing for posting the proof of a given block? No?
No.
Okay.
Not at the moment. For sure, there will be in the final design, but for the sake of the integration, we just want people to be producing proofs and uploading them. For incentivization purposes, we'll be running a contest behind this, and part of the criteria for picking winners out of the contest is going to be timely, both the number of proofs generated and also timeliness. So in that matter, yeah, longer than 10, 20 minutes, absolutely. So yeah, time will be a factor if you're shooting for winning, which we hope all of you do. But yeah, there will be no hard restriction that with at the very least that we anticipate for here. So what's happening next is we're actually turning this into a formal request for integration that will get posted on the Aztec forum soon, probably before the end of the week. And we'll be opening up a test network with the specs that we just shared around the week of August the 12th. That means that you guys will be able to start testing your proving infrastructure at that point. That network will be open for development. The idea is to freeze the release by then, but we may ship a couple of updates if we see that that's necessary. That will be properly announced via the forum and also the Telegram channel that we have. We expect that anyone who wants to participate to just share on the forum that they are interested in participating, include an L1 address that we can use for identifying them. And then in September, once everyone has had enough time to spin up their prover nodes, to integrate with their existing infrastructure, we'll formally start the context, which is basically that we'll officially start tracking how many blocks are produced by which entity and in how fast they're also produced. This tech be shared after the call? Sure. Don't see why not. Yeah, Angelo.
I have another curiosity. Do you know more or less what's the cost for basically posting this each block and get basically pay for the verification? I assume, right? It also verifies when you post the block. So yeah, in terms of gas, L1 gas.
This is going to be running on an L1 fork. It's not going to be running on the actual one, so it's going to be absolutely free. We'll be dripping fake ETH to every L1 address that wants to participate, so you don't have to worry about that.
All right, thank you.
For the real thing, Joe, correct me if I'm wrong, but I think we're talking about $1.5 million
Yeah, currently we have a verifying solidity for the proving system honk. It's 1.5 million gas. It's not been optimized yet. I think Zach's confident, our resident optimizer is confident that it can get it down to kind of like maybe 800,000 gas. Yeah, for now, though, as Paula said, this will be on a test network, so no need to worry.
Thank you, guys.
Absolutely. Besides that, and that's also related to another discussion, which is the frequency at which we want these proofs to get uploaded. Like we can have longer epochs, which means that we get a more amortized cost for verifying these proofs, but we get less frequent L2 to L1 messaging. So that's something that we'll be fine-tuning as we go. So yeah, next steps will be posting this formal request for integrations. We expect people to express they're willing to participate. We'll be opening up this test network so you can start playing around, asking questions and telling us what breaks for you and how we can help. Steven, correct me if I'm wrong, but the idea I think is to do 2 more community calls before the contest officially starts. And yeah, then when we run the contest, plan to announce winners. And for sure, this won't be the last integration network. So we hope you guys that you guys stick around for further integrations where we test either generating proofs for epoch, for whole epochs, where we test sequencer prover coordination, and we keep scaling the complexity of the network until we get closer and closer to what mainnet is going to look like. So yeah, that's basically it. This is the timeline that we're just discussing. Yeah, we'll basically leave it open for questions. And aside from your questions, what we're most interested in is if the design that we're considering for this prover node and this potential integration with prover agents, whether it makes sense or not for you guys, whether we're thinking about the interfaces correctly or we're completely wrong and need to think this from the ground up in a different direction. Actually, let me go back to the design that we're discussing.
Yeah, the only other question as well for feedback is just on the timeline. Given kind of engineering teams and their loads, is 4-ish weeks enough to do an integration based on what you've read so far? Morgan.
Yeah.
So I want to confirm my understanding about how you expect the contestants to go about this. It seems like given the timeline, like what people could do for this is stand up some hardware to run the software that you guys have already written on our hardware, right? Like in principle, this contest could be approached by like maybe trying to find algorithmic improvements in Aztec proving, but given the timeline, we're basically just going to be running the software that you guys wrote. Is that a fair assumption?
I think there's 2. If you go back to the design page, there's two approaches. So you can do that, but this is kind of you're relying on Aztec software to win the contest then, and that's kind of you don't really have an edge there. And I think depending on your proven network, it may make sense to integrate at another point. But yeah, it depends on kind of your long-term ambitions and whether you think that's the best chance to kind of win. There's a large degree of different proven networks on the call, and some people may take that approach and just spin up hardware. Other people who've got kind of more like blockchains behind their networks may take a different integration approach. So I think it's kind of let the proven networks do battle and see which is best. But that is one valid approach.
Yeah. To expand on what Joe mentioned, like aside from the approach of running exactly the software that we're providing, we expect people to get creative in this interface between prover node and the prover agents as stateless proving infrastructure. Like we see that as the main integration point for existing stuff, and like it should be perfectly possible to code the proving agent from scratch, relying on Aztec's Barettenberg and ACVM libraries, just integrating with whatever infrastructure or whatever layout you have today. Like the code for the proving agent is really, really thin.
Yeah, and what other things based on the winners? We are thinking of kind of picking at least 2 winners across different categories, and so when we create the contest, people will kind of be asked to register in what category. So yeah, we can also use that to incentivize more complicated integrations versus kind of simply running things out the gate. And so we may ask if you're doing kind of a custom integration to post a GitHub repo, so we can kind of verify what you've been doing.
Regarding the questions we have in the chat, it's mostly CPU and RAM hungry, I would say. Again, these numbers are subject to change, but we expect to share more accurate numbers before this initial version of the test network goes live on the week of August 12th. We also expect you guys to report what we're seeing and make sure that it matches our own numbers. And in terms of geographical restrictions, Stephen, I think this one is for you, but I understand that the more diverse, the merrier.
Yeah, absolutely. I think during this first initial phase of development, there's not going to be too much in the way of restrictions. But as Joe kind of alluded to, there's going to be several different stages. And I guess that kind of relates to the other question we had on like the custom versus like Aztec software approach. Like I think if you are taking that like default software approach, it might be better waiting for some of the later stages of the testnet.
Angelo?
I have a silly question. So, how does it? Is the proof that each of the prover is supposed to submit on L1 deterministic, or what I'm trying to say is the identity of the prover embedded into the proof, or
yes,
as a cheating? Okay, all right.
Yeah. There is literally one of the outputs of the root rollup circuit is a prover identifier that you can configure when you spin up the prover node. And basically, that's what prevents other provers from
exactly.
taking a look at the L1 mempool and submitting the same thing. Yeah,
a lazy prover, right?
Yeah.
Long term, that'll be used for kind of like sequence approval coordination and can be used to kind of, do fees, rewards, those sorts of things as well. But yeah, in the meantime, it's just to make sure that your proof is yours.
Mm-hmm. Sorry, Justin. There was a question about the prover node on Aztec GitHubs. It's already there. Everything we do is completely open source. I can paste the link to the repo actually right now. Give me a sec.
And yeah, just a reminder, so we won't be tracking kind of progress on the initial integration test network from the 12th. Like, so you have time to fail and kind of make failing proofs for a period before we start tracking in early September.
Mm-hmm. Okay, Vanishri?
Hey, thanks. So a couple of questions. One is when we are integrating the prover verifier on our network, if we have any questions, should we just ask in the shared channel, or is there someone in your team who we can ask questions directly to?
I think the shared channel is fine. We'll be, I think I'm there already, Phil as well. We'll be keeping an eye out for technical questions. And if not, the forum is also a good place for asking questions, like whatever works best for you.
Mm-hmm. In the event that we are not aiming to optimize the prover, is it okay if we get integrated now and just to test things out? So I think for us, the goal will not be to win this contest because we won't be optimizing the prover on our site. Would it still be okay that we just get integrated, be ready for when actually you're generating proofs? Is that okay?
Yes.
Yeah, 100%. Yeah, okay. Please do. If we get 10 different prover networks integrating, I think then we can then move on to kind of coordination and those things. We're more kind of trying to split things up so that if there are different types of prover networks, one type doesn't dominate. And so we get a bit of diversity, because a bad outcome for decentralization would be that every prover runs Aztec software. And yeah, we have an opportunity to kind of have people integrate a bit more deeply. And if they're willing to do that today, that's great. If that's going to take a bit more time, then no problem. Just be great to see you producing proofs.
Yeah. Thank you. One last question.
Yeah.
So when you're doing this contest, the outcome of the contest is, I think, a one-time, as far as I understand, it's a one-time, some sort of incentive, some sort of prize. But that's just in one snapshot of time, and after that, whoever wants to generate proofs for you will get integrated, right? It's just a one shot thing, and then move on to the other stages of the testnet and mainnet, right?
Yeah, so we'll kind of just pick some winners to make it fun, but it's completely permissionless. Like if you kind of don't integrate for this stage, but you come in later, you can do that. It's our goal is kind of over time, like I guess the most efficient proving marketplaces should dominate, but we just want to make sure that sequencers have a good choice between them, so they can pick based on geography, how their kind of philosophy aligns with marketplaces and all sorts of things. So it'll be permissionless.
Thank you.
Yeah, just on that as well, Joe. Like, and when we're talking about contests, like there might be like a small stipend, but like we are expecting it to be pretty competitive, right? So it's just to have something there for to say thank you more so than anything else.
Awesome.
Yeah. The main goal here is to try to get as many people producing proofs as possible. And that's the reason why we designed this particular network to be a free-for-all proving and not a first one wins. That's why the contract is just going to allow as many proofs for a given block as they want to be submitted.
I see. And then what are the metrics you're going to track during this? So one is, of course, the time of proof generation. So can you give us a little bit more insight into the exact metrics you're going to track during this contest?
Rate and time, the number of blocks that every prover has managed to prove during the span of the contest, and given a tie, the timeliness. Basically, what's the time difference between the block getting posted to L1 and that proof being uploaded.
Awesome.
Yeah,
Thank you so much.
Reliability is kind of, I guess, the first metric. And on point 3 on this slide, we may try and vary like block sizes, block kind of makeup, so that over the course of the contest. So, you may have to spin up more or less nodes. So it's just trying to build resilience as well. But we'll post more details about that later on. At the moment, I think just assume small blocks. But as Paula said earlier on the call, we may try and throw some larger blocks in there to see who's resilient and who can actually respond to that demand to make sure it's more about reliability.
Thanks so much, guys.